Good afternoon, all. Uh, Thank you for joining our today's webinar on SPICE simulation made simple. I'm Saira, working as a team lead EDA here at the SAS Systems in Bangalore. Today's webinar is under recording. If anyone having any questions during the presentation or during the demo, please type your question in the chat. Now, let us jump into the today's agenda. Today, I'm going to begin with review the benefits and challenges of simulation, followed by an introduction to LTM built-in simulation capabilities. Then I will be providing a demonstration and will be having a question and answer session, and we will be concluding with that Q&A. Now, let's discuss about the benefits and challenges of simulation. Sorry. Simulation allows you to evaluate or even analyze the designs under a wide range of conditions that would be difficult to duplicate in a lab environment. You can simulate using artificial blocks as shown and use the same tools and environment as a design move towards a more granular level of implementation. Monte Carlo analysis allows you to gain visibility into worst case component variation scenarios and provides a means to improve yield, reliability, and quality. The easy what if analysis allows you to insert component substitutes into existing designs to provide an easy level of pre-qualification as substitutions are considered. Simulation provides an extra level of design due diligence that can reduce the number of hardware prototypes that will be required during the design cycle and allows you to complete the project sooner and at lesser cost. The time required to achieve reliable simulation results can be detoured away from design rather than a means to accurate design. Semiconductor vendor support for device models span a range of model formats, and support for these formats is essential to enabling timely simulation. A non-integrated environment can also make project-level data management more complex, requiring users to either forego or implement their own version control solution. Sharing and collaboration can also be a challenge when the simulation capabilities is not built into the schematic design. Now let us see how we can able to perform simulation with the simulation support available inside the RTM designer. Now I would like to introduce RTM simulation capabilities. Simulation is available directly within the design context of schematics and is facilitated through with the guidance of simulation dashboard. The dashboard provides a single panel view to assure all prerequisites to simulation, such as model, signal sources, and analysis setup are in place before execution. If a problem is identified, the dashboard provides links to easy correction. RTM provides a set of generic electronic components and function blocks with models ready to simulate. This provides design with a rapid way to try out different approaches to circuit design. In this side, I have included a few analog and digital blocks, an amplifier, AC motor, voltage controller switch, and a JK flip-flop. As I mentioned earlier, model support is a key, and RTM simulation engine supports analog PSPICE and LTSPICE models. This includes PSPICE library files with extension .lib with multiple model definitions. This opens the door to a wide range of device supported. RTM allows designers to access models anywhere from a managed server, local file system, generic models, and directly from parts listing with the manufacturing parts each panel. This opens the door to the rapid creation of components with full parametric data that not only have symbol, footprint, and 3D views, but also the proper simulation model, all with RTM single click component acquisition process facilitated by Octopart. Simulation is a part of Altium business project structure. We see here in the projects panel that models and simulation specific parts of the design are included with the other designs and PCB aspects. This optimizes organization and allow you to extend the built-in version control capabilities of Altium PSPICE to the simulation domain. The waveform display is treated as a separate tab in the same unified project, just like schematic, PCB, or active bar editors. You can tile view, probe across schematics, and perform cursor-based measurements of wave results as shown here. Version control assures that designers are always using the current version of a model and provides a way to resolve simulation settings across committed versions. The project history shown here gives you a timeline view of what has been commented, and the changes that were made. Designers can choose to open a snapshot of a commit or revert to specific commit with mouse click. Whether you are interacting with an FAE from a device vendor or team member, the extension of the simulation context to RTM for sharing and collaboration capabilities gives teams an edge as they address today's complex designs. In this example, a waveform is inserted into a schematic and forward to a colleague to assure results are meeting the expectations. Now, let us have a look about the simulation capabilities of the RTM designer with a demo. Now, let us jump into the RTM designer. Now, here I have what is I will. This is a circuit which is a bandpass filter. Today, I'm going to use this one to perform the SPICE simulation. Before we jump into the SPICE simulation, we have to make sure this simulation tab you are accessible or not when you open the schematic sheet from the project. Let me close this other panels which are open. When you open a project under when you open a schematic sheet, if you didn't find the simulate tab, that means the simulation extension is not installed. To install the same, we just go here and go to extension updates and just go to purchased. Under purchased, you should see this simulation should be tick mark like this. If it's not there, if you see download symbol, then click on download and it will ask you to restart the Ultimate Designer. Please restart the same. And after opening your schematic sheet where you want to perform simulation, you'll be seeing this simulation tab. Just leftmost click. We have a couple of options available under this command. Run simulation. If you press shortcut key F9, it will perform the simulation, but we don't know what the settings is being set. For that, we have a simulation dashboard, which is available since Altium 21, where allows you to perform a different kind of checks like ERC check, model first verification, source file check, and as well as we can able to perform the AC sweep, DC sweep, transient analysis, operating point analysis, Monte Carlo, other kind of analysis you can able to perform by using the simulation dashboard. And we have option to place sources, like we have placed some virtual sources, and we can place the models from here. Uh, and you can even space the simulation generic components which you have highlighted. As you are aware, for running the SPICE simulation, you need to have the SPICE model available for the component. If in case if your component you are looking for don't have the SPICE model, you can able to use this simulation generic components. If at all the component is equivalent to this generic model, you can just place it and you can able to perform the simulation with using this simulation generic components, which is available from RTM 21 and later versions. Okay. Yes. And we have other options like placing your probes. You can able to place a voltage reference, current probes, and even you can place some initial conditions if you want. Now let us see the simulation dashboard, how it looks. When you open a simulation dashboard, a panel will be open at the left side, or you can talk it right side, left side, your wish. And here we asked you to affect a document. This is the interesting thing here in RTM21 later versions. Here, you will getting a provision to perform simulation on document level as well as project level. In earlier 21 older versions, you can only perform simulation on the current active document. But from since RTM21 and later versions, we can choose specific document which is currently open or all. I have only one document. I have chosen one. If I want to have simulation performed on all projects, I can able to choose this option for performing the same. And first, we have 4 steps in the simulation. The first one is verification, which will verify your circuit for any ERC, ethical rule check will be performed for any ERC errors, and it will check for model files are available or not for your component. Okay, I think we just do the perform verification. Before that, let us see what and all things we have. We have properly set the sources or not, because this virtual source I have based from this simulation sources. This will be can be found in the default libraries where item is supplied. From there you can install, you can able to place it. This VRC, VRCN. Now let us see. Yes, this is source 15 volts. This is being this is source 15 volts 982. Okay, that's fine. Now let us click on start verification. Once click on start verification, yes, it pass. Okay, fine, that's nice. And the second step in the verification is it is being asked these components don't have model files. Would you like to assign automatically? Yes, I'm happy to get assigned automatically model files. Yes, it's been assigned in the components. I think there are 2 components away. Yes, here I could able to tool could able to assign the model files for the all the passive components except the active component. Yes, then what to do? Yes, we need to add the spice model. Where can I get? As I told, you need to get from your component supplier or vendor. And if this component is meeting to your the any generic component available, you can able to add it. Yes, I don't have that problem. I have the library available locally. Yes, you can browse it. You can able to use it. Or if you have a model file available as part of library, yes, I have I will use it to perform. Or you can able to pick from server, or you can able to pick from the manufacturer part set. Now I have the library available with me. I just want to map it. This is the model file, how it looks. And once the model file is added to the component, you need to map the pin, schematic pin with the model pin. Here, the first pin is offset null. Here, the model pin, the first pin is non-inverting. Then in case it's a not connected. Second pin is inverting, inverting. Third pin is non-inverting. First pin is inverting, non-inverting in the model. Negative voltage 4, 4, fine. Offset null 5, not connected. And 6 pin is output, 5th pin is out. And 7th pin is positive voltage, 3rd pin is positive voltage. This is very important. This pin mapping is very important. Like this, you have to map the all the pins. This is very important. Okay. Then click OK. Now, once it is mapped, it will be moved to the next step, preparation. Under preparation, here it is showing. Sorry. Under preparation is showing the voltage sources it has found automatically. V1 15 volts and V2 minus 15 volts, and V impulse is 1 volt peak to peak. It has been found. Okay. Now, if you want to add any additional source with tool fail to pick, you can able to click on add, you can able to add. And under probes, we have option to add voltage, current, power, and other stuffs. You can able to add it. And further, we have the analysis setup. And analysis setup, the first one is we have got the operating point analysis. Before running any analysis, we have to perform this operating point analysis. just click on run. How it is being performed, and V in is 0, and you can see the voltage over on the each net. You can see here 15 volts as it is 0. That's why it is showing as a 0 V input. And power, we also see power and the current as well. You can get all the voltage at a time. And even you can perform the transfer and the positive analysis. And we have a DC sweep. You want to know the sweep of your DC circuit with respect to any source, you can able to perform. I want to have a DC sweep with respect to V1 and the output expressions. I can pick, I can able to run the analysis. The next one we have is uh, transient analysis. Here in transient analysis, it's like analysis like oscilloscope. How we'll see the waveform from the oscilloscope. The same you can able to get here. You can able to choose what is the input and output. You can able to choose output expressions. You can able to specify whether it is interval based or period based. You can have the from 1 to, and you can able to click on run option to get the analysis. See, this is the input and this is the output. Okay, if you want to have the cursors, right click here. You can able to add the cursors, and you can able to place the cursors here, and you can able to go to sim data to see the what is a and what is a B, and the cursors where they are located at the XY locations, and what is the difference, A minus B, frequency, and rise time, fall time. All this data will be shown here. And if you want to add additional plot or a waveform, you can able to add a plot, and you can able to give the some meaningful name to the plot and say next, and a plot is will added. Then you need to able to pull this one to the next tab. We're going to see the different waveform outputs, and we can able to export these outputs to chart, plot, or a waveform. Okay, like this you can able to do the same, and you can able to change it, or you can able to you can able to delete the plot. Okay, this are you can able to do the cursors, and you can able to do the measurement. And next we have is a Monte Carlo analysis. I think many other people will be knowing by giving the different values of the components, how your outputs are varying, you can able to perform. Let us see how you can do with the help of this SPICE simulation engine inside the Altium. Just enable Monte Carlo analysis and click on settings to enable some settings. Here, Monte Carlo, number of runs, how many you want you can do. You want the distribution, Gaussian, worst case, what you want you can able to perform, and what the components you want to have the tolerances, you can able to check, and what is the percentage you can check, and just click OK. And which type of analysis you want. I want to see the how the transient analysis behavior with the help of Monte Carlo. I want to check. Just run the transient analysis. This is the Monte Carlo analysis of your design. So this is how your output list with reference to these values. If you want, you can able to do the masking level. Okay. This is the value with respect to this value with the different colors. Okay. Like this, you can able to do this. Okay. Like this, you can able to perform the Monte Carlo analysis. And at the end, we have got the results. This results tab will help you to access the any kind of results from here. You know, to road profile, you know, to edit a description, you know, to do the same. Okay, this is how we can able to easily perform a simulation using the Altium Designer. Now, if you want to share this with your colleague, this waveforms and all, just simply save this project. Just click on save to server. And you can able to, you know, see now it has been now, as I told you, I have pulled this one from the cloud. I can share with my colleague who is want to review these designs, I can share with him. Okay. Just I want to only view axis. Yes. Yes. Share. I think we have a question from the chart. Let me have a look. Is temperature option is there for Monte Carlo? Yes, I believe it's available. Let me finish up this and I will show you the option. See, now it's been shared with my colleague, and I just open my colleague email ID from here itself, so that people can see how you can able to collaborate with Ultimate with a live sharing of your outputs. This is the design, and we can ask, we can share design. You can be able to comment. Is the input is correct? And you can able to put a comment. You can able to specify the person whom you want to assign. Okay, I get task and post it. And if you go back to the alternate designer, just go to the comments and panels. You can able to see the comment has been available here. If you click on this, it will show the where the location comment is enabled. I can look and I can say yes, or I can do some changes and I can able to reply him back. Reply with say resolved. Now, if I go to the see, now it has been like this. You can able to real time communicate with your colleague for reviewing your design with the help of the alternative. Okay. Yes, coming to the that query temperature sweep option. Yes, I believe it is available. Let us see. We have transient AC sweep. I think temperature sweep is available, I believe, for AC sweep. I'm not sure. As for AC sweep, it's not for Monte Carlo. It's not available for Monte Carlo because what all options are available here, which we need to perform any one of this. Temperature sweep will be option available for AC sweep. Monte Carlo is available for AC sweep or DC sweep transient, but not temperature sweep. Monte Carlo sweep can be performed here. Okay, this is the one. Okay. Is any other questions? Any other questions, team? Yes. To summarize our today's session, we have showcased you how you can the new simulation dashboard help you to perform simulation, how easily you can add the model file, and how you can map your schematic and the model pin mapping, and then later how you can do that verification process, uh, and then later we have showcased how you can perform the simulations, operating point, DC sweep, transient, Monte Carlo analysis, and we have showed you how we can able to connect with your colleague through Alt-65 for reviewing of your design. Yes, this is all about this today's webinar on spice simulation made simple.